Hey, let's say I'm given two angles and one side in this triangle. Okay, so somebody give me, if you looked at this angle C and I asked you to guess what is that measure, what might you guess? 100? Okay. So let's assume that's 100. Okay, and what about angle B? What could we guess angle B would equal? 30 what? 37. All right. So if you have those two angles, now what piece of information? So remember, A is opposite side A, C is opposite, or I'm sorry, A is opposite angle A, C is opposite angle C, B is opposite angle B. Which of these pieces of information, A, B, or C, would I need in order for this pattern of AAS to hold true? Two angles and a non-included side. Okay, so here's our two angles, 137. What's the only included side? What side is included between those two angles here? A. So either of the other two would work, right? Okay, so let's say we were given a measure for B. So what could we pick as a length for B? 7. All right, so let's say these were the three pieces of information I was given. Okay, does everybody see how this fits the pattern of AAS? We have two angles and a non-included side, so that's where the pattern is generated. Okay, and so if you're given a problem like this, you'll usually be asked to find all the other pieces of information for that triangle. So we need to find angle A, we need to find side A, and we need to find side C. Okay, which of those would be the easiest thing to find, given this information? We have two angles. How easy would it be to find the third angle? Yeah, really easy. All you have to do is take the total sum of the angles in a triangle, which is 180, and we remove the two angles that we were given, 137, and that's going to leave our angle A, which is 43 degrees. Okay, so the first thing is find your missing angle. Winds up being easy to do. Okay, next, we can pick either of the two pieces that we want to find, either side A or side C. Let's say we want to find side A. And whatever your unknown is, I would always start with your unknown in the top left of your equation. Okay, so our unknown is A, so I'm going to start with the ratio A over the sine of the angle opposite A, which is what measure? We just found it to be 43. And that's going to equal, and you always, in the law of sines, you have to have a known ratio, a set ratio. So which is the ratio that we actually had both the side and opposite angle for? The A's, the B's, or the C's? B's, right? Here's our known ratio. Since our side is on top, we need to start with side 7, and we take the sine of the angle opposite that, which is 37 degrees. Right, and so all we need to do now to solve for A is either multiply both sides by sine of 43. Okay, so that gets rid of your fraction, leaving A. So we can calculate that. 7 times the sine of 43 divided by the sine of 37. Okay, I can hit enter and I get my solution 7.9. All right, now our last piece of information that we need to find is C. So I'm going to do the same thing. I'm going to use law of sines one more time, but this time to find our unknown C. So I always begin with my unknown in the top left of my equation. So C over the sine of the angle opposite C, which is 100 degrees. And that's going to equal my known ratio. Again, the A's, B's, or C's, it's the exact same thing that I used here. Since C is an unknown side, I'm going to begin with that known side 7 over the sine of the angle, the known side, or the known angle opposite that, 37. Okay, and so I could either multiply both sides by sine of 100 to solve for C. If your unknown is a side length, you can use the solve feature on your calculator as well. So I'm just going to call that x over sine of 100. Set it equal to 7 over the sine of 37 solve for x, and that's going to give me my solution for C, 11.5 approximately. Okay, now the last thing that you can do on here is use a couple properties from geometry to test the consistency of this. And one of the things in a triangle that you should vaguely recall from geometry is that in any given triangle, the longer side is opposite the larger angle. The shorter the side, it's opposite the smaller the angle. So is that consistent here? Is our longest side opposite the greatest angle? Yeah. Is our shortest side here opposite the smallest angle? Yeah. So that's at least consistent. It allows you to kind of check for the consistency of it. The other piece of information in a triangle that can be used to check the consistency is the sum of the two smaller sides always has to have a total sum that's greater than the longer side. So is 7 plus 7.9 greater than 11.5? Yeah. So again, that's consistent in that respect as well.